Okay, so I'm going to um, show you what we have um, with the network, with the local coder, and what is my direction. Okay, so just so you know, I have local coder here. Currently, it's in the blueprints, and it is a submodule. So this is entire local coder as is from Git, but I have done a little bit of additions. I try to not change anything, because it's your project, and I like the idea that is contained in your responsibility. It's your project. It's a huge building block. In my opinion, it misses not much, only a couple ideas, and a lot of people would adopt that. In my honest opinion, it has a great RP in several directions, and if it gets a small chat box or some adapter UI, just like a library UI maybe, to plug in, it's like you can basically say I have the drop in AI for all your projects. The way the local coder is currently easy to integrate, it only needs a little bit of adjustment to work in a custom tool. So I have spent a little bit of time because I wanted to always have it inside the VMX context running at runtime inside TrueOS. So I am maybe at 95%. So there's only a little bit of web application logic missing, okay? So there's just a bit of the request and actual communications and multi-threading that I really need to do careful memory mapping, and it has to do with how local coder is, of course, based on Tokyo. But I can tell you that if I build local coder in my world where Tokyo and these ideas are basically directly running on the silicon, I feel the local coder. This is one-to-one from your GitHub. And here's an extra folder, it's distribution, and here you find your binary file. And it is currently sitting at 5 MB, but usually that is a little bit bigger than what the footprint of the binary would be packaged at full opt level. So if we go to the blueprints and then to the distribution, it is not included here. Maybe it's in the apps. It is as well not included here, but that is actually a small back check. This is the watcher server. That's wrong. Final BP copy step. Can you do a look back and check for me? Local coder BP was already kind of at around 1.7 MB due to the packer respecting all the lips and things. However, we had to build the local coder as Ubuntu CLI to integrate with RADs right right away. That is not a BP concern, and it's only runtime rats scope-wise. Please find why the packer builds it again at size 1.5-ish MB instead of the used 1.7. That may very well be an up step we did towards cargo BP and the packer. Thank you. He says thank you, right? That is actually just come to my attention, you know. I will let the AI give me a good answer. I hope I hope the answer is going to be accurate, and I'm going to be like fine with that answer. So I have here local coda in the blueprints. It's not the blueprint currently. It's not proven what it does. It's not like I didn't use it inside the VMX context as a full app. Still not yet, you know. I work on this for long weeks, or let's say months, on the blueprints, and it is actually so much up high in the user space that it is so like difficult. It's way more difficult than I thought, but it's as well giving me the entire story to what these network libraries and a lot of Tokyos needing at runtime, you know. So that is the great concern, that it's going to be available as a client, as a CLI command line tool in the TrueOS, just as a blueprint. People can just download the app, you know. And the rats is actually where I want to hint you at, because this is open source. It's not, this is user space. It uses a lot of advanced stuff, you know. There's absolutely no reason to hold back. Let's use anyhow. It actually does use a lot of things that I already can, you know, kind of do in TrueOS, but here's Auxum, and these are not yet in our OS, you know. So this is meant to run on an actual, on actual Linux, Windows, like high-level web browser available, you know. And what is going on here is we just, we have to start it, right? And it has your local coder here. This is a symlink. It means local coder is available to the TrueOS Red Studio as the integrated AI agent of choice. That means if you want to develop an app for TrueOS, you're going to do it the new way, not a blueprint, but you're using probably the Rapid Application Development Studio by now. And this is what I just started, because it is actually like a small dream of mine that you have a very strong development framework for a very strong operating system. And what we're going to do is now we watch that in action. So without further ado, I say this, I will refresh the cache, do a reload, and now you can see this is integrated with your local coder. Okay, you remember here, this is like the small thing I did. You get to choose your stuff here, what you want the AI to do, what not. And the model, this is just, how can I explain, you know, this is just your work. And now I can do like, you know, this is actually insane. Okay, I told you how strong HTML and CSS is as the UI description language. There's no reason to not do HTML for a UI. There's no reason to skip CSS if you want to define how stuff looks, okay? So what I've made is a small integrated development environment. So you go here, you make a new TrueOS app, and you get to choose from these templates. You want to do a Canvas app, tool window, service app, blank app, shell app. And we can talk about how this is named and stuff, okay? It's all details. But you can just do your app, and then you have your apps. And here you have your main window, and on you can design live, you know? You design live your UI, and then you have Rust here. And you have Rust, and there's events, main, UI. This is your blueprint, but it's integrated. You can check, build, and pack this, or you just go full auto mode, and this will give you the blueprint, okay? This is your app development platform, so to speak. Like I will put everything here that can make and help with apps. And the most important part kind of is AI needs to be here and help, you know? Now you have Rust, events, main, and UI. And now I say, hello AI. I need another Rust file that is a helper that lets me reverse strings. Please. Now we just give AI this prompt, and due to your perfect tool integration and everything so high level and in the user space, Yun, you're going to get a response soon by the OpenAI endpoint. It's still going to do some building, some whatever, but you can see that it's done, you know? It worked in the background. It created the helper. This helper is new, you know, it just got dropped in live and hot. Everything's okay. That is in full auto, so the BP got rebuilt, you know? We have the Hello UI blueprint right now. It's already ready to distribute. And here the AI gives me beautiful response on how this worked, you know? I said, I need another Rust file, please, you know? And you get this, yeah, glob, read, right, edit, done. Edit new Rust helper. Yeah, where is it? Oh, yeah, it's here. You know, this file was not here before. Now it's here. And it has your function that reverses string. And if it's like, I mean, it's like too small for you, it's like you can go here and you just go 115%, you know? And you have like your properties, like I need this button and then Rust. And the nice part about this is that you know that this is minimal coding. This is so actually this entire IDE, everything you see here uses it's just a nice little prompt. Use the Rust toolchain, do everything in user space, have high level web UI, and in the end, why you get a small kind of project like TRUEOS Rats, the entire project, including compiled local coder, is oops, it's huge. Because I just said, yeah, do a user space monstrous construct. But the source is actually pretty small. This is all there is actually. 10 files in Rust, your local coder integration, some main, and a little bit of web stuff around that, so the UI is polished. And this is currently the state of local coder, and what I have in mind. I want to have it in my development environment, and as well, Yun, I want to have local coder soon, again, fully available in VMX context. All of that, like there's way more to show by now. Like I will give you a quick demo on the blueprints and how far everything has come at runtime. So this is now not the IDE anymore. This is now TrueOS again. And let me show you, like, you know, these cursors and stuff. Yeah, that was fun. Was fun for a day. You can get your crap And now you have a crop cursor. Okay, we got that. We have the shell. We know the shell is fully working, you know? You can just click, type into the shell, and it's going to be just a working shell, you know? There's actually no downsides. Like I can set for 150 here, so it fits the window. I'll do like, I don't know, files, see my files, you know? I can select text here. This is the shell. I mean, it's a shell. It's a nice analog clock. I don't know, like this clock needs to turn once so it's fully updated. This clock does actually 0 effort in rendering. And it's a ultimately low performance clock that just updates a small stroke. Like, it's an analog clock. Why do I talk about that? This is now Swarm. And Swarm can give you connection to other TrueOS. That is because we have a burn we have a burn backend. And the burn backend is calculating in AI interference on the fly if we enable these services. It's currently disabled. So we have done a lot that we don't need OpenAI endpoint. We can actually interfere locally in the TrueOS, and as well, like what happened is like all these apps are now inside the actual VMX. Like, you know, these are like 20 apps that just get delivered with that. You know, it's not auto start now. You can just go and start the chart. And then you have here, inside your VMX context, a fully virtualized and isolated app that has a UI window, and you can just pause the VM. This is a virtual machine, okay? It's an app inside a virtual machine using Rust and Tokyo. And it's not only pretending. At this point, that's completely done. You have every kind of loading aspect to that. And we have more apps. We have a currency app. The currency app lets you convert, like it does some network. Oh, it's broken. Never mind. It does some network, just does not look good, and it gives you currency information. These apps can do network, multi-threading. These apps can access file system. So we have more demos here. We have Flags. That's a small game that gives you flags, you know. It goes to a CDN. It downloads SVG, it render the SVG, and it lets you play a small game where you have to say, oh, this is Norway flag. Now, what's the Norway flag, you know? And it's a pretty fun in the sense that you have to click the correct flag and it should load the next. But this is already going across network, so it's a pretty fun thing. And you can just pause it, and you can also pause that one. But just so we start some more apps, you know, there's a particle. Even the bigger apps are now supposed to work. Like here is an app that completely froze our UI. Or did it? Well, no, it did not. Where's my particle system? Did it not launch the app? Oh, that's so difficult. Sometimes a lot of things happen here. It's pause request. Okay, what apps are running? Chart, currency, flags. Okay. What app can we start? We can start Tetris, Hello World, Mandelbrot. What is that? Patterson? 10. Okay, let's start the Patterson graph. We should get a small, nice little graph somewhere. Or maybe the UI is confused. Let's do a quick restart, actually. Add CPU reboot will always get you up to... you need to go into command mode, add CPU reboot. And we do a nice, small, contained reboot, just so we get these apps up. I don't want to check this logs. It's trivial, mostly trivial stuff here, right? But I don't want to check all these logs in detail. Like, this is important, Cortex. And then we just check this app again. There was the flags, right? Want to see the flags? We have seen the flags. Framework, no. Hello world, hello world. Pretty boring, maybe. Mandelbrot. Particle and Patterson and Retro Sun. We should see all of those now. Should see at least the particle demo now. Okay, particle demo is up. I will make it big. There was the 9. Let's see the 10. Okay, the 10 is the Patterson graph. I can see that's a reasonable. It's a graph, right? I mean, it gets dynamically built. There is a Retro Sun available at the 10. Let me see. Retro Sun. This is the 11. Let's see our Retro Sun. Okay, so the Retro Sun is just like, it's like this classical kind of nerd thing. The Retro Sun is a beautiful kind of sun. And where the other apps kind of demonstrate aspects, for example, we have live weather data. So this is going to connect to some weather server in Germany. It's going to fetch the latest weather data. And currently it is probably loading the old API endpoint. So there's a lot of, there's actually a lot of things to consider if you have multiple apps running. And given that we have such a good foundational work now, it's actually the easier and more fun part to work on that there is and make that better. It's not so much we need a lot of new features here. So let's go with another small, do a small reboot again. So we're at the clean boot. And we're looking once at the weather app because it's a high-level app, and I don't see why we would not want to see some weather data here. So I'm in surf mode. That happens, I guess. Needs to go to app mode. And I'm a little bit baffled on that one. No, it's for the second time. So I did not want to start the Mandelbrot. Just happened. You can always, this button, you can just hide the UI. We just hide the UI. I don't know if that button makes any sense. You can just remove that if you ask me. So there's still no weather going on. That may just be, let's try again if we can get another weather app in. Also, it has no window Chrome, It's kind of suspicious if I believe I removed the window Chrome. You see here's our updated weather. So it has a geolookup time mode. It used some saved coordinates. So that's exactly my coordinates. Here's where I live. Longlet in Holzminden, Germany. And here you can see live weather data for the next 7 days. So I'm quite happy that Saturday, Sunday it will be 20 degrees and I can spend some time outside.